This is section 6.3 and 6.5 today we're doing, because 6.3 is the graphs of sine, cos, which we already know, and then we're going to add tan to it. And 6.5 is the graph of the reciprocal trig ratios, trig functions, but we're going to just do them together. Because when we graph the original sine cos, we're going to do the reciprocal the way we did reciprocals before, with the invariant point, the asymptotes. Remember the 4 steps for doing a reciprocal function? We're going to use those 4 steps and graph it, right? So we might as well do the 2 sections together, because I need sine to graph cosecant. I need cos to graph secant, right? So we're doing the 2 sections together. So if you're wondering why I put the 2 sections together. So the first step is we're going to graph sine, talk about it, and then we're going to do cosecant and talk about it. So I'm sorry, I didn't put an axis on here, so just put an axis somewhere in the middle-ish, right? So middle-ish, it doesn't have to be exact, right? I don't even think my squares are even, but so somewhere there in the middle, that's my x. And then somewhere in the middle-ish for the y. Okay, I didn't label the axes, I should have. And then I usually do every 3 squares is a tick mark. And remember, when we do the sine, we haven't done this for a little while, when we do sine, there's quarters. 1, 2, 3, 4. 4 quarters. That's the way I always taught it in grade 11. So we went quarters. And sine has to go from -1 to 1. You can put 1 and -1 anywhere you want. I'm going to put it over here. At 1, I'll use 2 squares, just so I can see it better. You could put it at 1 square. It's up to you. Right? I'm going to do 2 squares just because I get a better shape. I don't need too much else. So I'm going to do 2 squares as 1. You can do 1 square as 1. If I label it, you have to follow whatever I said, but in this case, you're allowed to label it. Okay, so then we're going to draw sine. Sine starts, and this is why I did the quarters. I go 0, start to 0, up to 1, back to 0, down to -1 in here, and you're going to draw a beautiful sine graph. The only difference that we're doing now compared to what we were doing before is that here, instead of putting 360, I'm putting 2 pi. Okay, so I'm putting 2 pi instead of 360. So 2 pi instead of 360. Then I'm going to continue this and go, okay, this is now pi. Does that make sense? And then this would be pi over 2. Right, we know how to do this. Half a pi, 1 pi, so this would be 3 pi over 2. You don't have to label them all, but just so we know that we're now in radians versus degrees. Technically, I just need the last one labeled. I just need one of them. I need 1 tick mark labeled. Any of them. You can do the first one. You can do any of them. I just need 1 unit on one of the sides labeled. Just like I have here, I don't have to label every square. Okay, but that's how we break it down. All right. I want you to take this. I want you to continue the pattern, because it is periodic, and fill the graph. So let's go further. So as much as the graph as you can fill, please fill it. We're going to do the same thing. So every 3 squares, like this. I want to continue the pattern, which means I'm going to head downwards. And I'm going to head back up. And I'm going to do more. So as much as wherever your grid wants to stop, then you're going to do that. So I'm going to ask for, it doesn't say how much to graph. I just want to do this so you can see the pattern. From that, we can now answer everything. We can answer it without the graph too. So the period is how long before it repeats itself. So if I was to grab 2 pi, I can grab those 8, those 1, 2, those quarter sections, and I would need 4 of those sections, and every 4, it's going to repeat itself. So it doesn't matter which part, 1, 2, 3, 4, it repeats itself. So that's what that period means, is that if I was to cut this, this is where I would cut it after those 1, 2, 3, 4 sections, so 2 pi, so that I can repeat, repeat, repeat. It's like a stamp. So if you're saying I'm going to stamp it, this repeats itself. So that is my period, 2 pi, not 360. The sinusoidal axis is the halfway point in between the max and the min, which is at y equals 0. Right? That's the halfway point. I always, always, always want the equation. Okay, so please remember, whenever we answer this one, it's equation. We don't say equation, but we mean for it to be equation. So have to remember it, it's an equation. And that's the halfway point between the top and the bottom, right? The max and the min. So halfway, right? We know the definition of sinusoidal, halfway. Halfway between max, min. Right? So if you're forgetting your definitions, sinusoidal axis is halfway between the max and min. Amplitude is how far up from the axis it goes, which is 1, and how far down it goes, which is 1. So it's 1. The amplitude is 1. The max value is 1. The min value is -1. Top and bottom. The domain you can write it in set notation or interval notation depending on what we ask for. Sometimes on the top of a test we'll say write an interval notation, sometimes set notation. Let's do set only because over here when we do the restrictions, we're going to have restrictions, and sometimes those restrictions, when you say does not equal, it's much easier to write it in set notation. So let me do set notation for now. We're going to do it for x as an element of real, right? And then my range would be from y is an element of real, and it's going between 1 and -1. So -1, and you can write it in either notation. I'm just going to do set because I'm going to do set with the bottom one anyway. All right, so that's it. We know that, and the only thing I did was I changed it from 360 to 2 pi. Everything else we know. Now, we're going to do the same thing except for the reciprocal. So first, I would like to be able to picture what the reciprocal looks like. So before I can do anything, I need to be able to picture it, right? Because I like to visualize. So for me, visualizing it does help. So I'm going to take all of this, and I'm going to use my reciprocal knowledge, how to graph a reciprocal. So there were 4 steps to it, well, 4 parts to it. Didn't matter what order you did it in. One of the steps was wherever it's 1 and -1, those are my invariant points. So these are my invariant points. I'm just going to highlight those. Those are my invariant points. 1s and -1s, right? So we know this from reciprocal time when we did the reciprocal. 1s and -1s are invariant. Those points will be both on my reciprocal and my original. Another step, right, there's 4 different parts, was that wherever it's 0, it's an asymptote. So wherever it's 0, it's an asymptote. So 0, asymptote, 0 is an asymptote, 0. Look how many asymptotes, it's so pretty. Look at this, and zeros are asymptotes. So go as far as your graph goes, depending on where you put your axes. And yes, it does continue. Like it goes beyond that. I just stopped it there because that was enough of a pattern. Okay? Sometimes we'll say draw 1 period of it or 2 periods or something like that. Okay, so everywhere it hits 0 is an asymptote. What else do we want? Oh, that's it. So then the rest of the graph was, it says, wherever it's increasing, it's now decreasing. Wherever it's decreasing is now increasing. And then the other part was wherever it's positive, it's positive. So since it's positive here, it'll stay in this quadrant, right? It'll stay up here, not down, not quadrant, but like above 0. It won't head down here. So we know the graph must be here because it's positive, stays positive. Wherever it's decreasing, it's now increasing, and it's following the asymptote. And wherever it's increasing, it's now decreasing. So it's the opposite. So my graph is going to look like this. And it actually continues, and it goes up the asymptote. So it keeps going and going and going and going. Yay, beauty. Isn't that pretty? There you go. Now when you know what to draw on all your Christmas holiday cards, anything you give someone, wrapping paper, that's going to be on it. You mean like, look, I drew sine and cosecant for you. You're welcome. Right. There you go. Pretty. And we'll do some more. There'll be pretty patterns. So this is literally your only pattern you're drawing. Okay. There we go. Now we're going to answer our questions. So what is the period? The period here, so how far before it repeats itself? So if you were going to make a stamp of this graph, can I stop here? No, because it's not here, so I need 2 pi again. So I need these 2 sections to repeat. So you're saying how much before it repeats? 0 to 2 pi. That makes sense? So it's still 2 pi, so it's going to be 2 pi. I'm doing this in 2 pi. Okay. Vertical asymptotes, where do I find them? I find the vertical asymptote at 0, pi, 2 pi. What would it be next? 3 pi, 4 pi. You see the pattern? Negative pi, so it's every pi. So how do you say every pi without writing the words every pi, you're going to say x, oh, it's an equation, so you're going to go x equals, it's a vertical, right? I need the equation equals, and then it's going to be, so oh, never forget the equation, people always do that. It's every pi, 0, pi, 2 pi, 3 pi, 4 pi, so it's going to be every k pi. And k, you're going to say it's an integer. There you go. Okay, so every integer. And it goes positive to negative. That's why I was showing you it follows the same pattern on the negative side. Yep. Yes, I was going to say, you can use the Z or the I, right? So again, in grade 9, we used I, but now most of the university books, I think, use Z. I don't know why our books ended up using that, so capital Z, right? So either one, all except either one. I'm pretty sure the university books only use Z. I was taught with that. I don't know what happened with the I there. But then I'm like 9,000 years old, so I don't know. Things change, right? Mountain shift, right? So, but I'm pretty sure the university books, look that one up, but I'm pretty sure they still go with Z. Again, I am 9,000. In university, we were in a cave, we wrote on the walls. Yeah, it was a lot of work. Berries, we had to collect berries, and we like dipped in for the ink. Yeah, it was a lot of work there. Chased by, bears. Okay, here we go. So max value, is there one? None. Just a trick question. There isn't one. There's an asymptote. Min value, again, trick question, nothing. There is none. Okay, if there isn't one, there isn't one. The domain. Remember, so domain, from our graphing that we did before, the domain is always related to the asymptote and holes. There's no holes, so it's related to this. So these two, the domain, always has to look back to any asymptotes. So look here, and you're going to say it never equals there. So that's why I said the set notation is actually a lot easier in this case, because then when you write this one, you're going to go x is an element of real, but x cannot equal those. And just grab that and say, yeah, those. The k pi, where k is an element, right? Like that. So I'll accept either one, I or the z. Again, I don't know why we did I. Okay? And then the range is, it had, so not looking at the blue, right? So not looking at the blue, it's the pink, so it's going to be heading down from -1 and heading up from 1. So we're going to say that the range is going to be y is an element of real, and y is going to be less than or equal to -1, or, and you can use or the symbol, greater than or equal to 1. And that way, this one was easier to write in set notation. When you say something can't equal, it's easier to write in that notation. Okay, when you're ready, flip over. We're going to do the next one on the next page. I left it really spacey, so that's all we have to do for that. There's a bunch of extra space on the bottom there. Okay, and we're going to do the same thing for cosine. Ready, flip. So graph it. Yeah, when you Google integer symbol, it's capital Z. So try to use that. I don't know why we went to I, right? And I know all of our grade 9 notes, we went to I. It must have come out from some book, but when you look it up, it should be Z. Okay, so try to use Z, because again, when you go to university, if you have to write that symbol, they'll be like, what are you doing? Okay, so let's use capital Z. Cosine, sorry. Somewhere in the middle-ish, wherever you want. And that's y. Again, I'm going to just use 2 squares just so you can see it better. You can use 1 square. And I do every 3 squares as a tick mark. And this will be 2 pi. Right, so I don't have to label more than that. That's good enough. Cosine, the difference between cosine and sine was that it starts at the 1 and heads down. Okay, so do that, and please repeat it as far as possible. I want to get a nice pattern, right? I want to fill the graph so it looks really pretty. So it goes to, so do the same thing here. I'm going to go as far as possible. I'm going to go one more tick mark here. So that's my first period. And I did every 3 squares. I did tick, tick, tick. And I'm going to continue the pattern. Is that all right? I'll continue it this way. So I'm going to keep going. So down, goes down to -1. There you go. All right, so go a bit further. Okay, and the only difference is that we are using the pi symbol. Period is 2 pi. I'll start filling it in because it's the same. The axis is still at y = 0. The amplitude is still 1. Max is 1. Min -1. The domain is anything. Right, so this is all the same thing as sine. And the range is from -1 to 1. There we go. And for the secant graph, we're going to use that same reciprocal, right? The 4 steps that we have for the reciprocal. We're going to do the same thing. So it's going to be the same pattern, but shifted over a little, right? It's going to be the same beautiful pattern that we're getting. So highlight your 1s and -1s. So all your 1s and -1s stay where they are. 1s and -1s. And all of your 0s are now asymptotes. Okay, your 0s are now asymptotes. What color would you like to use? I'm going to use orange. Okay, and it's exactly the same idea. So wherever it's decreasing, it's now increasing. It stays positive wherever it's positive. It stays negative wherever it's negative. So instead of decreasing, it's heading up. And then instead of increasing, it's heading down. Right, so down, up, opposites. And look at this gorgeous thing. You can go longer if you want. Like it continues. My graph just stops. Don't tell me that's not pretty. That's pretty. And we want to just answer the questions.